Hey, this is Dr. B, and let's take a look at the chronological development of the periodic table going back thousands of years up to roughly modern day. Thousands of years ago, there was fire, and if you put a rock over a fire, it might ooze out some pure elements such as gold or perhaps lead. And the early humans, no doubt, experienced this and eventually worked with it to create things. And as a result, there were some simple elements that were largely believed to exist thousands of years back. These ancient elements, things like lead and mercury and gold. I'm thinking of the low melters. Eventually, this could extend to copper as hotter fires were developed. So, before Christ, some metals were known. Let's move on to the era of instrumentation, which was in the latter half of the 18th century. The double pan balance started to show up, and precision for that balance started to get developed. People such as Antoine Lavoisier took advantage of this to weigh things. And a lot of things can happen when you weigh something, especially if you know its volume as well. You can differentiate things based on density. Back then, they used a simple notation. I believe this was known as Dalton's notation to characterize some of the early elements. And perhaps 23 or more were discovered by 1790. Let's move forward to 1810 when a different device got created, and this was by Alessandro Volta, who created the first working battery, known as Volta's pile back then. And we now know that at one end of this system, electrons are being added, and at the other end of the system, electrons are being removed. This allows you to isolate pure elements. Copper oxide can be reduced to copper. Things like that. The halogens got discovered. All sorts of unstable elements can get created using this kind of a system. And so by 1860, some 70 elements had been written down. And now you've got cards, if you will. You've got data. You've got a pack of cards that you could arrange in different ways. And people started noticing patterns. One of the first people to see that was John Newlands, who discussed the elements in terms of octaves, in terms of patterns of 8. Wow, he was onto something huge. We now know that, with rare exceptions, all elements have up to 8 valence or outer shell electrons. This works pretty well for the first 2 rows, but as other blocks kick in, notably the D block, the patterns get a little more obscure. There's still a pattern there, but it's more complex than simply a law of octaves. So John Newlands, although he is known as the father of periodicity, is not really known for this law because this law was disproven. Mendeleev, on the other hand, had a more practical approach to things, and perhaps he dressed in more of a practical style. He simply went with what worked, and from that he was able to cobble together a periodic table that seemed to show some patterns, right? 1 valence electron, not sure what those are doing there. 7 valence electrons, not sure what that's doing there. It's rough. There's errors in it, but some of the patterns were pretty clear, and for some of these patterns, he's noticing little missing sections. His big accomplishment was predicting what the properties would be for these missing sections, and when they turned out to be right, the idea of the periodicity and a pattern to the elements really gained some structure, and so he is really the father of periodicity. And many elements by 1900 had been organized and categorized. Early periodic tables existed. In 1929, something pretty surprising happened. People started to make new elements. Isn't that something, right? Isn't that like playing God a little bit? This device here, which looks a little bit maybe like a rod and reel, is in fact an early particle accelerator. The idea being that somehow this device can take atoms and smash them into one another at such a velocity that they either fuse or break apart and form new elements. This happened, look, like 80 years ago. Glenn Seaborg really took advantage of this and discovered all sorts of elements, and the synthetic elements began to be a thing. It must have been a time of great promise when you imagine that you can create your own elements. It seems like you could change the universe as it existed. What they largely determined was most of them had such instability that they fell apart almost as soon as they made them. If you move forward to more recent times, we're still smashing atoms together, but now our devices are more the size of towns rather than the size of something that might fit in a lab. And with these devices, we can do larger collisions, but we're still discovering elements that are very, very, very unstable. And it shows its way into some Hollywood movies. So the recent efforts have been towards synthetic elements. This is a brief history of the periodic table.